Good morning, one and all. I am Dr. Ramya Swetha. Today our topic is ground improvement techniques. One of the case study we consider, that is Yamuna Expressway. So in this particular case study, what we understand in terms of ground improvement techniques as a civil engineer. As a civil engineer, we have to understand any type of case study, what type of project it is, and what kind of soil properties are there in that particular locality, and which type of technique choose or technique, what kind of ground improvement techniques gives the results for better results for construction of that particular project. These three are the major parameters we have to keep in our mind for any kind of project when we are considering in ground improvement points of view. These are the three characteristics we have to understand: what type of the project, where we are using, what kind of facilities is required for that particular project. These are all the parameters we have to understand. So in this particular Yamuna Expressway, it is nothing but a roadway. So first we have to understand the overview of that particular projects. So what kind of various parameters which are involved in particular about that project. So it is a construction work, and that too relevant to the road. It is relevant to the road construction. So it is expressway, it is nothing but the roadway. So in this roadway, how much strength or stretch is involved in that particular roadway or expressway? In that, what kind of geographical changes or soil changes are there, or there may be total, whatever the project we are dealing. So the complete area may be considered same kind or not, whether they are having same kind of soil properties or not. We have to analyze all these parameters and whether it is suitable, the suitability. And once the project is final from any kind of ends, whether it is from government and other, whatever it may be the reason, once we finalized the project, we have to understand what are the various scenarios involved in this particular parameters. So here, as a ground improvement techniques understanding point of view, as a civil engineer, in terms of geographical and geostatic properties, based on all these parameters, we have to enhance the properties for constructed the better resulted highway, expressway. So here for that we have to understand the what are the requirements for construction of the highway, and what are the actual parameters are there, what we required parameters. So we have to understand the required parameters and what are the expected or what are the need for that particular project, what kind of parameters we required. So what are required and actually what kind of parameters are there. So actual parameters. So once we understand these actual parameters, move towards to enhance these required, we are going to reach this, means we require this ground improvement techniques. Ground improvement techniques. So these ground improvement techniques, what we have to analyze. So we have to analyze various parameters, those are involved in this particular characteristics, and the materials, what kind of materials we are using, what type of scenarios are there. These are all the parameters we have to understand in any kind of the projects. So here what we have to do in this particular project, first we have to understand what kind of background of this project have. That is the main thing. The first one is the locality, From there only we will understand the what kind of soil properties and other scenarios also, what are the various characteristics involved in that particular locality. These are all the parameters which we are going to involve. And in the complete stretch here, this approximately 165 kilometers. So in this, through from the starting point to ending point, we may not expect the same kind of the properties. So in between, what is the purpose of the project and what kind of experiment or what kind of expectations are there on that, these are all the involved parameters for construction of any kind of project. So here the purpose is to reduce the travel time between the Delhi and Agra, enhance the connectivity and support economic development in that particular region. These are all the various parameters which are involved in each of the reducing travel time. It has their own kind of social elements. So according to financial elements, this economical growth of the country depends upon these kind of reducing travel. So once this kind it is going to develop that particular locality, so such type of development is required in rural regions. So that is the main purpose. So once we decided and we know the where it is and what kind of challenges are there in that particular locality, we have to understand those challenges. In this, it is the stretch is 165 kilonewtons, means we have to understand the varying soil conditions are there. So the various kind of soil conditions are there in that, including loose fills and soft compressible soils. So in this kind of scenario, it is highly difficult to construct such kind of expressway. It means heavy moving loads are there. Not only passenger vehicles, we may expect heavy moving loads. So any industrial exchanges nearby, any ports, whatever it may be. So this all kind of scenarios we have to analyze. We are considered as these challenges, how we are overcome those challenges and how we meet this purpose of that particular project. In this particular project, expressway, it is nothing but the roadway. It is located in Uttar Pradesh, India, connecting Greater Noida to Agra. So this from Noida to Agra, that approximate 165 kilometers, it means it is going to reduce the travel time between two cities, one major city to the one metropolitan city to the other city. So that connectivity gives the n different number of support to the economical growth of that particular region. So in this, what kind of challenges we are facing? So the first thing is the varying soil conditions, including loose fills and soft compressible soils. These are all the parameters which are involved in this particular scenario. Now move on to this importance of the project, this economic impact and so safety improvement, strategic significance. So in this economic impact, facilitate trade and tourism, supporting the local economy. The safety improvements reduce traffic congestion on existing routes and provides a faster, safer alternative. And also the strategic significance forms part of the larger infrastructure development plan connecting to the major highways and economic zones. So these are all the various important parameters are we consider. Few more parameters are also involved in this particular project. So the facilities, once we consider, whenever it reducing means it gives so much strength to that local people to get their business. It's easy to easy business. So this kind of local supporting economy is going to improve because of these kind of roadway facilities once we improved in any country. And also because of this road highway, it completely belongs to the transportation system. So once what is the old path, it is there. So they are going to from Delhi to Agra, that is going to reduce, and it leads to encourage the reduction of the traffic the conjunction of the traffic of that particular existing route which they choose, people how they choose from Delhi to Agra, that is going to reduce. So it means it provide once faster and a safer alternative. And also the strategic significance forms part of the larger infrastructure development plan connecting to these major highways, and they are as economic zones. So in this, for this kind of soils, what we understand, because of these variation is there, various kinds of soils are involved in this particular 160, more than 160 plus kilometer stretch. So it means we are going to choose widely for ground improvement technique because of the versatility and the different kind of soils are involved. So that way we are going to choose the ground improvement technique is dynamic compaction. This dynamic compaction, what is meant by dynamic compaction? So whenever the ground improvement technique where the soil is densified by dropping a heavy weight, so once we choose, because of these are all silt and clayey soils, so that's why once we drop those heavy vehicles on repeated mode onto the ground surface from significant height, it is going to, the compressibility is going to reduce. So in this, to reduce the density of the loose granular soils, thereby improving their load bearing capacity and reducing settlement under structural loads. So this is the main objective. So here we are going to improve the load bearing capacity and reducing the settlement under structural loads. These are all the parameters which are involved in this particular case study. So we consider that is for this dynamic compaction as our ground improvement technique. So here, what kind of process we are following for this ground improvement techniques, that is weight, drop height, energy per drop, impact. These are the involved steps in this dynamic compaction mechanism. So how much weight it is there and from which height we are going to fall these heavy weight to the soil. These are the parameters for how much compressibility is we are getting, and also so leads to the enhance the soil load bearing capacity, all these parameters. So here typically steel or concrete weights ranging from 5 to 20 tons. From the dropping height is usually 10 to 30 meters, and we are going to calculate it as the weight multiplied by this. So from, for example, a 10 ton weight dropped from 20 meters delivers 200 ton meters of energy per the drop. So this impact, so this is all, this is nothing but the impact load we are creating, because heavy weights we are thrown from the certain height, that gives the shock waves. It creates some shock waves. So the impact of this weight create these shock waves that rearrange soil particles into denser configuration. They are in compressible and they are not in dense format. Once we done this impact process, the dynamic compaction, that gives shock waves, and it is lead to the rearrange all soil particles into this denser configuration. So this kind of mechanism is involved in this dynamic compaction. Where we are using this kind of dynamic compaction, this DC is nothing but the dynamic compaction technique which we choose for this particular Yamuna Expressway. So here this is ideal soils like loose granular soils such as sands, gravels and fills. So these limitations less effective in cohesive soils and very fine silts due to the permeability and poor drainage. So this kind of low permeability conditions and also the drainage system, there may lead few or different scenarios we are going to understand. These have their own limitations with suitability of this dynamic compaction. So here where we are applying this application of this dynamic compaction in this particular Yamuna Expressway, the site conditions. The soil compaction, the expressway site included loose fields and soft soils, and also in between these the soil variation between the soil conditions we are going to observe in along this strength. So because of this we are facing these kind of various challenges, that is whenever the dynamic compaction is affects the load bearing capacity, but it has their own kind of compaction capacity of the soil condition. So this complete stretch has not have the same kind of soil strategy. So it has their own different kind of scenarios in complete along its length. So now it means we are facing this same kind of effect from starting to end point of these uses of these dynamic compaction techniques may not give the same result. We may consider, for example, 10 tons till from 10 meters heights from 0 to 165 kilometers through this expressway gives the differential settlement and also the load bearing capacity. So this we have to understand, we consider it as a challenge because this differential settlement leads to the risk of uneven settlement due to the varying soil properties. Because at 0 kilometer to 1 kilometer and 1 to 2 or some sort till x kilometers, and after that from x to 165 in between so many x1, x2, x3 we may add. So they have their different kind of soil properties. So we may consider this dynamic compaction even though within the intervals we have to maintain the differentiation of the impact load what we are creating. So otherwise we are going to face these kind of differential settlements as well as load bearing capacity of the soil having their own, we are not going to maintain because of this uneven settlement. Due to varying, we are going to face this risk, and also not need to ensure that soil could support the heavy loads imposed by the road structures and also the traffic. So like this we have to understand how we are implementing these dynamic compaction. So first we have to understand the soil testing and also the trial compaction. So these are considered as preliminary investigations. In this soil testing, extensive geotechnical investigations to determine the soil properties including density, moisture content and also the compressibility. These are the properties. This extensive geotechnical investigation we are choose, and also this trial compaction test sections were compacted to determine the appropriate weight, height and also the grid spacing we are providing. So we have to understand that interval to how much weight, how much drop height gives this even settlement from starting to end point of this is also important. These preliminary investigations helps us understanding about the soil properties as well as the how much compaction is required for getting the uniformity of the project. So in this, the compaction grid pattern in this dynamic compaction was carried out in grid pattern typically with a spacing of 4 to 6 meters. So in this, multiple passes were made with the weight dropped on each grid point several times. So this monitoring surface settlements measured to assess the effectiveness of compaction, and also the penetration test, those are conducted before and after to evaluate the improvements in the soil density. So here in this dynamic compaction, once we consider for this grid pattern, the spacing is varying between 4 to 6 meter, and also multiple passes are made because of the how much weight we are dropped from the each grid. So how many times also plays a role. So this surface settlement, the effectiveness, how much the surface settlement, that uniformity gives the, that monitoring gives the better results. In this, before we are going to conduct this penetration test before and after, that also evaluate the improvements in this soil density. We are understanding the soil properties in various parameters. In this results, this soil improvement, it is going to finally, once we choose this dynamic compaction, it is going to enhance the properties of the soil as per the required of the project. So in this dynamic compaction also, soil improvement, increased density, reduced settlement, homogeneity. These are the parameters which are involved as a result in soil improvement. Whenever we are choosing as ground improvement as our technique. Ground improvement technique is dynamic compaction. So in this, so we are going to enhance the, we are going to increase it. This density, increased density, significant increase in soil density, reducing voids and improving load bearing capacity, and also decrease, it is reduces the settlement because of these heavy loads, impact loads are, it is going to be denser the configuration. So soil, so that's why this decrease in a expected long-term settlement, ensuring the stability of the expressway, and also more uniform soil particles across the treated areas, reducing the risk of differential settlements. So in this, what kind of challenges we are facing in dynamic compaction? Environmental concerns. So in this environmental concerns, this noise and vibration, because of these heavy loads, we have to choose the timings is important whenever we are doing this kind of dynamic compaction, and also we have to check nearby surroundings, how much nearby, what kind of weight we are taking, and how much fall from height, from which height we are throwing into the soil. These are all the parameters we have to keep in your mind at the time of doing this dynamic compaction, because of the surrounding areas are going to impact, or because of these vibrations the nearby surroundings are experienced. So because of this nearby surrounding, any heavy structures or light structures, they are capable or not, because of this heavy impact loads, they are bearable, if that is bearable or not also plays a role, because it may destroy the nearby small structures, or without foundation any kind of sheds like parking areas what we provide, they may disturb. So we have to understand nearby surrounding also once we choose this dynamic compaction, it plays important role. And also these environmental concerns in this noise and vibration, because of this impact, noise and ground vibrations could affect nearby structures and communities, because we are going to choose the odd times. So we have to choose for better results in environmental concern point of view. And also the, because of the soils are very fine, so they are silty, very fine particles. So because of this, once this potentiality comes into it, so they give some dust generation. So potential for dust and debris during the compaction process, this is also one of the environmental concern we have to understand. We are going to reduce how much we can. And also the soil variability, from this kind of long length stretched areas, we choose this ground improvement technique, dynamic compaction as our ground improvement techniques, that plays a different role in various scenarios. In soil variability we are going to facing, so here this heterogeneous soils and groundwater. Thus, variation in soil types along the expressway required careful adjustments of compaction parameters. And high groundwater levels in some areas could reduce the effectiveness of dynamic compaction. So this soil variability also one of the challenge which we are faced whenever we choose these dynamic compaction as a ground improvement techniques. So in this structural considerations, so these adjacent structures and utility lines we have to understand. So protecting the nearby buildings and infrastructures from the effects of vibration which are created by these dynamic compaction ground improvement techniques. So in this dynamic compaction, this is going to, we have to adjust and also ensuring that underground utilities were not damaged during this compaction. So these kind of structural considerations also we have to kept for understanding about these ground improvement techniques. In this, what kind of solutions we are going to implement? So vibration monitoring, adjusting compaction parameters, dust control and pre-treatment in sensitive areas. So because of this vibration, the nearby structures are going to affect. So continuous monitoring of these vibration levels to ensure they remain within the safe limits of surrounding structures or not. So that is also one of the important parameter when we choose these dynamic compaction as a ground improvement technique for any particular project. So here the vibrations levels are going to change, means we have to change our method for getting the required enhancement of the soil property. And also adjusting compaction parameter, once we are going to modify the weight. So once that weight is going to beyond and the drop height is also more, means we are getting the more vibrations they may affect. So that's why we have to adjust those modifying weights and drop weights and grid spacing on the site specific conditions. As per the site conditions, nearby any structures are going to affect, means we have to modify. As per the site specific conditions, we have to understand. And also in dust control also, implementing dust suppression measures such as spraying water, that is going to reduce the effect of the dust coming out from these soils. This pre-treatment in sensitive areas, in areas with high groundwater, pre-treatment methods like dewatering were employed to enhance the compaction effectiveness. So underground also some pipes, we may provide different kinds of scenarios are there. Once we drop these heavy weights from the certain height, from drop height, they are going to damage. So we have to do these sensitive areas are there. So the pre-treatment is required, such as these like dewatering techniques we have to choose. In comparative analysis, we have a different type of ground improvement techniques other than dynamic compaction. So now we are going to compare this dynamic compaction versus other ground improvement techniques, that is cost effectiveness. Dynamic compaction is generally more cost effective for large open areas with suitable soil conditions compared to the other methods like deep soil mixing or stone columns. And also the speed of construction. This dynamic compaction can be rapidly implemented, making it suitable for projects with tight schedules. In limitations, less effective in causue soils and also requiring alternative or supplementary methods. In different types of highways also, we may compare the use of dynamic compaction on the expressway with other projects like Mumbai-Pune Expressway or Delhi-Gurgaon Expressway, when different ground improvement techniques were chosen due to varying soil conditions. These comparisons also we are going to understand. In long-term performance and monitoring, post-construction monitoring. In this, the post-construction monitoring, settlement monitoring, payment performance. In regular monitoring of settlement over time to ensure the effectiveness of dynamic compaction. And also evaluating the performance of the payment structure, including any signs to distress or failure. In maintenance considerations, routine inspections, repair strategies. In regular inspections and maintenance to address any potential issues arising from residual settlement. In repair strategies, approaches for addressing any localized settlement or pavement distress that may occur over the time. Like this, we are going to understand. And also in environmental and social impacts. So in environmental impact assessment, discuss the finding to this environmental impact assessment conducted for a project focusing on the impact of dynamic compaction. In mitigation measures, measures implemented to minimize environmental impacts such as a noise reduction strategies and dust control. As per the social impact point of view, community engagement, efforts made to engage with and address the concerns of local communities affected by the project, the compensations and relocation policies for compensating affecting individuals and relocating those in pathway of expressway. Final summary points what we understand from this as a conclusion in this dynamic compaction proven to be an effective method for improving soil conditions like the Yamuna Expressway, and also various challenges were successfully managed to the careful planning, monitoring and adoption of the techniques. So importance of site-specific investigations, monitoring and community engagement in large infrastructure projects are lessons we are going to learn. In future consideration, in advancements in dynamic compaction, potential advancements in ground in equipment and techniques that could enhance the effectiveness of the dynamic compaction in future projects. And also considerations for making dynamic compaction and other ground improvement techniques more environmentally sustainable. So in this, when we discussing these environmental parameters for this expressway, particularly in the relation due to the dynamic compaction, so it is important to consider several factors that influence the local ecosystem and also human health, sustainability. So here we are some of the key environmental parameters which we are considered, that is noise pollution. So the impact of heavy weights we are dropping during the dynamic compaction process generate significant noise. So this impacts human health. Prolonged exposure to high noise levels can cause hearing losses, stress and sleep disturbances for nearby the residents. And also wildlife. This noise can disrupt local wildlife, particularly birds and other animals sensitive to the ground animals. So these are the impacts which they are creating from these kind of noise pollution. In this scheduling, limiting dynamic activities to daytime hours to minimize these kind of disturbances, and also because of these sound barriers what we provide installing, so temporary noise barriers around the site to reduce the spread of the noise, and regular monitoring about these kind of noise levels. So that regular noise level monitoring to ensure compliance with local noise recognition. In vibration effects in this dynamic compaction, so as per these dynamic compaction we have different, we may observe these. In this dynamic compaction ground improvement techniques, after noise, we may affect these vibration effects because of the dropping of heavy weight induced ground vibration that can propagate through the soil. So here the impacts are structural damage and also the underground utilities. In structural damage, vibrations may affect nearby buildings, potentially causing structural damage, particularly to older or weaker structures. As per underground utilities impacts, so vibration could disrupt underground utilities like water pipes, severe pipes and various cables which are involved in this ground level. So we are going to understand in this mitigation vibration monitoring, continuous monitoring of vibration levels to ensure they remain within the safe limit for structural and utilities. And this buffer zone, establishing the buffer zones where no dynamic compaction is conducted near sensitive structures. and also reduced energy drops using lower drop heights or weights in sensitive areas to reduce vibration intensity. And the one more parameter, that is dust and air quality. The impact of the weights on soil can generate dust, especially in dry condition. They are going to impact the air quality and visibility. Dust particle can contribute to air pollution, affecting the respiratory health of the workers and nearby residents also. So in this visibility, dust can reduce visibility on nearby roads, posing a safety risk also. So in this, the mitigation we are considering, that is dust separation, air quality monitoring, personal protective equipment. So regular watering of the site to suppress the dust generation, and also implementing the air quality monitoring to track dust levels and take corrective actions if necessary. And also the personal protective equipment, providing PPE such as masks to workers to protect against dust inhalation. These are the various parameters which are involved in this. And also the soil contamination, because of the potential for contaminants to be released during the dynamic compaction, especially if the site includes industrial waste or polluted fill materials. Thus impacts groundwater pollution and soil quality. Contaminants could leach into the groundwater, affecting water quality. And also soil quality, long-term soil degradation could occur if contaminants are not managed properly. In this site assessment, conducting through the site assessments to identify and remove any contaminated materials before dynamic compaction. And also containment, using containment strategies such as geotextiles to prevent the spread of contaminants during the compaction. The regular testing of soil and groundwater quality before, during and after dynamic compaction to detect any contamination. So in groundwater impact, so because of these, dynamic compaction can potentially alter the permeability of the soil, affecting the movement and quality of groundwater. These impacts are aquifer recharge, water table fluctuations. So as a impactor of these aquifer recharge, changes in the soil structure could affect the recharge rate of the local aquifers. As a water table fluctuation, this compaction could cause fluctuations in the local water table, potentially impacting nearby wells or agriculture activities. As a part of mitigation, hydrological studies, controlled compaction monitoring wells are there. In hydrogeological studies, conducting studies to understand the impact of dynamic compaction on local groundwater system. And also controlled compaction, adjusting compaction intensity in areas with high groundwater levels to minimize impact. In monitoring wells, installing and monitoring wells to track groundwater levels and quality during and after the project also. So in mitigation and land use, the construction and dynamic compaction process may involve clear vegetation and altering the land surface. So in this, habitat loss, erosion are the impacts which we are understand. So in habitat loss, clearing vegetation can lead to habitat loss for local flora and fauna. In erosion, disturbed soils can be more prone to erosion, particularly if vegetation is removed. In minimizing land distribution, limiting the extent of land clearing to what it is necessary for project. Revegetation, implementing a revegetation plan to restore disturbed areas after construction. This erosion control, using erosion control measures such as silt fences and mulching to prevent soil loss during and after construction. In water management and runoff, so compaction can affect surface runoff parameters, potentially leading to increased erosion or flooding in nearby areas. Those impacts are flood risk, water quality. So in flood risk, altered runoff parameters could increase the risk of localized flooding. And in water quality, increased sediment in runoff can affect water quality in nearby rivers, lakes, or wetlands. In mitigation, drainage planning, sediment control, post-construction monitoring. So in drainage planning, designing effective drainage system to manage runoff and minimize flood risk. In sediment control, implementing the sediment control measures such as retention ponds or silts barriers to protect water bodies. In post-construction monitoring, ongoing monitoring of runoff and water quality to detect and address any issue that arise. In impact on local communities, so the construction activities including dynamic compaction can impact nearby communities in various ways. Those impacts are health and safety, livelihood disruption. So noise, dust, vibration can affect the health and well-being of local residents, and also construction activities might disrupt local business or agriculture activities. So due to community engagement, compensation and support, and also healthy and safety measures we may consider for reduce these impacts because of these dynamic compaction effects leads. So engaging with local communities to inform them about the project and address their concerns. And also providing compensation or support to choose affected by the construction activities by compensation and other supports as by the law. And also health and safety measures, implementing the health and safety measures to protect both workers and as well as the local residents. In regulatory compliance and environmental impact assessment, so legal framework, environmental impact assessment and environmental impact assessment remedies we have to understand. In this compliance with the national and local environmental regulations, including those related to the noise, air quality, water management and land use. And also in an environmental impact assessment would have been conducted before the project began to assess potential environmental impacts and outline mitigation strategies. In monitoring and reporting, regular monitoring and reporting on environmental parameters to ensure compliance with environmental impact assessment, and also adaptive management, adjusting construction practices based on the monitoring results to minimize environmental impact assessment. So in overall understanding and managing the environmental parameters which are dealt with this dynamic compaction on this Yamuna Expressway is crucial for minimizing the project's impacts on the local environmental and communities. By implementing the comprehensive mitigation strategies, ongoing monitoring and community enhancement, the project can achieve its goals while maintaining environmental sustainability. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.